Hi, today I'm going to look at how to do long division of polynomials. But before we do that, I'm just going to quickly go over the process of using long division. I'm just going to do that with numbers first of all. Let's say, for example, I've got 1,701 and I want to divide that by 7. So that's going to, I can also think of that as 7 times what value is going to give me 1,701. Let me set it up like this. 1,701 divided by 7. First of all, I'm going to look at how many lots of 7 will go into 1 or 9. So how many lots of 7 will go into 17? So that's 2. Okay, and 2 times 7 is 14. I'm just going to write that here. And now I need to find how many is left over. So I'm going to take that away. So 17 take away 4 is 3. Okay. Now, that's not my whole answer because it's actually 1,700. I'm going to bring my 0 down now. I'm just going to deal with this part of it. So now I need to know how many lots of 7 go into 30. So 4. 4 times 7 is 28. So if I take that away, that leaves me a leftover of 2. So I'm going to bring my last number down. Okay. And I've got 21. So now, how many lots of 7 will go into 21? It's 3. 3 times 7 is 21. Leaves me with 0. So there's no remainders. So I can say that 1,701 divided by 7 is 243. Or I could think of it as 243 times 7 is 1,701. Let's look at another example. Let's say this time I want to find 23 times what number is going to give me 5,336. So to do that out, of course I'm going to go 5,336 divided by 23 is going to give me that value. So I can set this out exactly the same way. So I've got 5,336 divided by 23. So just as we did before, I'm going to first think about how many lots of 23 will go into 53. Well, twice. So 2 times 23 is 46. And if I take that away, I'm going to find out what I've got left over with, which is 7. So now I'm going to bring my next value down. And I've got 73. How many times will 23 go into 73, or 73 divided by 23? Well, that's going to be 3 times, because 23 times 3 is 69. So if I take that away, that leaves me with 4. Bring my next value down, 6. Now, I've got to find out how many lots of 23 go into 46, and that's going to be 2. Oh, whoops. What was I supposed to do there? So basically said 2 lots of 23 will go into there, so 23 times 2 gives me 46, 0. So I've got no remainders. So in the 2 examples I've done, they've divided completely into the number with no remainders. So I can therefore say that 23 times 232 equals 5,336. Now let's just have a look at how this is going to apply to polynomials. So the first example I'm going to do is a fairly simple example. I've got x squared plus 9x plus 14, and I want to divide it by x plus 2. So it's not just a simple value or a number. I've got variables and I've got numerous terms. So remember, the other way I can think about that is x plus 2 times something is going to give me x squared plus 9x plus 14. I'm going to set it out exactly the same. X plus 2, and I want to find how many times that will divide into x squared plus 9x plus 14. Now the difference between this 1 and 4 is the fact that I've got 2 terms here, not just one number. So I'm going to deal with my leading term, my x, because 2 is a number and I can deal with it and I know what it is. But x is important because it's a variable, it can represent any number. And so it's going to be my leading term. So I'm just going to look at how many times this whole lot will go into my first 2 terms here. And I'm just going to deal with my highest power of the term. So how many lots of x will go into x squared? X, okay, because x squared is x times x. So it's going to go in there x times. So now, just as before here, I multiplied 2 by the 7, I'm going to multiply my x by this whole bracket here. So x times x is x squared, plus x times 2 is 2x. Now I need to take that entire thing away to find out what I've got left over. Okay, so x minus x squared is 0, of course, but 9x minus 2x leaves me with 7x. Now I've still got my 14, so over here, just as I brought it down to deal with my next part of my long division, I'm going to bring that down. So I've got 7x plus 14. Same again, looking at our first term, how many lots of x will go into 7x? 7. So 7 times x plus 2 is 7x plus 14. If I take that whole away, I can get left with 0. So I've got no remainders. So therefore I can say x plus 2 times x plus 7 equals x squared plus 9x plus 14. How can I check this? I can check this by expanding out. X times x is x squared. X times 7 is 7x. 2 times x is 2x. 2 times 7 is 14. Collect my like terms. That gives me x squared plus 9x plus 14. Let's look at another example. Say I want to find, I've got x times 3, oh, no, not x times 3, x minus 3 multiplied by something gives me x cubed plus 2x squared minus 9x minus 18. So if I've got x cubed plus 2x squared minus 9x minus 18, and I'm going to divide that by x minus 3. Looking at my leading terms, how many lots of x will go into x cubed? And the answer for that is x squared. So now I'm just going to multiply x squared by both those terms there. X squared times x is x cubed. X squared times negative 3 is minus 3x squared. I'm going to take that away. Now be careful here because I'm going to be taking away a negative. So I'm going to 2x squared minus 3x squared gives me 5. Minus negative 3x squared gives me 5x squared. Just as before, I'm now going to bring down my 9x. So I've got 5x squared minus 9x. Same again, looking at my leading term. How many lots of x will go into 5x squared? And that's going to be 5x. 5x times x is 5x squared. 5x times minus 3 is minus 15x. Taking away that again, negative 9x squared, take away negative 15x gives me positive 6x. Bring down my 18, and I've got 6x, take away 18. How many x's go into 6x is 6. So 6 times x is 6x. 6 times negative 3 is negative 18. Take that away, and that leaves me with 0. So therefore I can say that x minus 3 multiplied by x squared plus 5x plus 6 equals x cubed plus 2x squared minus 9x minus 18. And I could check that by expanding.